Yeah, so we have another problem. It's the same manner. We're asked to use the definition to prove this limit. Same thing goes. We know this is a limit of f of x, just that in this case it changes. You see, it changes. We are working with what? Plus l'infini is equal to plus l'infini, meaning our f of x is this, but we have a difference with the limit. This is completely different from what we've been treating, if you can see. So for this, there is a special formula for when you're treating the limit of function. The limit of functions when the limit, it's the limit infini quand x tend vers l'infini. So you're having a limit that is like to infinity, and then x tend vers plus l'infini. So we have a formula for that, which I'm going to give you. So we're going to do rappel au coup. So rappel from your coup, or if you've not treated that yet, but to find the definition of a limit infini quand x tend vers l'infini, like what you're seeing here, it will be for every a greater than 0, a assez grand, il existe un b plus grand que 0, tel que x plus grand que b implique que f de x est plus grand que a. So you can have this definition in your book. This is for limit infini quand x tend vers plus l'infini. This is the formula for it. When you have something in this form, like we have here, use this formula for the limit infini quand x tend vers plus l'infini. So, replacing this for our question, we go ahead with our question. We have for every a greater than 0, il existe un b greater than 0, such that x greater than b implique, what is our f of x? Our f of x is this. So it is x squared minus 3x plus 1 greater than a. Now, we're going to do something different again, a bit. But then it's something that works for it, okay? Which you can do it even in your own work, and it works as long as it is true. Just like we did for the last time, instead of us taking f of x minus 7 less than epsilon, we took 19 x minus 2 to be less than epsilon. So here, this is what it's going to happen. Instead of me having x squared minus 3x plus 1, I can find a number that is less than this. Okay? I can find a number that is less than this, and then it will also work. It's still in the same, like, should I say, I don't want to use the word domain, but I'm not using the word domain. No. It's still in the same, like, I just use the lame word, place. So it's, instead of having this, I'll have x squared minus 3x plus 1 is greater than x squared minus 3x. It's true. So we can use that instead. So what does this mean? It's equivalent to me saying x squared minus 3x plus 1 is greater than x bracket x minus 3. Because if I have this, I have x times x, that's x squared minus 3x. So this also works. So now we'll come back to using this x greater than b. We develop this part of the formula to get our f of x greater than a. If we can get x greater than b, develop it just so we can find what they're asking us to find. Let's go ahead. We'll be able to get it hopefully. So if I have x greater than b, implique if I because what am I trying to find? I'm trying to develop using this. Remember, we're no longer going to work with this because we said this is greater than this, so we'll work with this. So what will I do? I'll subtract 3 from both sides. Remember, because I'm trying, just like we did for the first question, trying to develop this again. I subtract 3 from both sides. So here I have minus 3, here I have minus 3. So what I'll have here is x minus 3 greater than b minus 3. And b is greater than 0. B is not greater than or equal to 0, but b is strictly greater than 0. So my b here has to be a number greater than 0. And what can make this to be greater than 0 as well? If I take b to be 1, it's going to be negative. B to be 2, negative. B to be 3, it will be 0, but it will make this to be 0, and that's not what we want. So we're going to take b to be greater than 3. You can take b to be greater than 4, but it has to be not the case where it will be 0, because we want to have b strictly positive. But me, I'm going to choose b to be greater than 3. You can choose b greater than 4 if you want, as long as it's greater and it makes this b minus 3 to be strictly positive. So I'm going to take b greater than 3. Prenons b plus grand que 3. Okay. So if I take b greater than 3, what am I going to have? Alors, x greater than b implique, remember we've done x minus 3, remaining this x. So here, I multiply here by x, and I multiply here by what? B. So if I multiply here by x, multiply here by b, what will I have? I'm going to have x greater than x minus 3, which is greater than b minus 3. And as always, b will always be greater than 3, greater than 4, or whichever one you decide to choose. Because what are we trying to get? We're trying to get this x greater than b. So if you might be asking, why didn't I do x here? Like why didn't since I multiply it by x, here should also be by x? Remember what we are trying to find. If we do that, we are going to start changing the formula that we want. So we can use, instead of using, like not instead of, that's why it is right for us to just go ahead with using b instead of using x, multiplying both sides by x. This is with x, so this should be with b. You get it. So hopefully I hope you get it. But if there's any confusion, you can put in the comment section, and then yeah. So we go on. So remember what we said, that this is because we have x raised to the power of 2 minus 3x. So I just go ahead doing the same thing. Okay, so I'll have x squared minus 3x greater than b bracket b minus 3. And remember what we did at the beginning. We said x squared minus 3x plus 1 is greater than x squared minus 3x. And now our definition, we have x squared minus 3x plus 1 is greater than a. So just like we've been doing, to have x raised to the power of 2 minus 3x plus 1 greater than a, il suffit de juste avoir x au carré minus 3x greater than a. It works, like it also works because it is true. So that's exactly what we're going to put down. So I'll write what I said. I said pour avoir x raised to the power of 2 minus 3x plus 1 greater than a, il suffit d'avoir x au carré moins 3x plus grand que a, like what we've done. And if you come back, you notice what happened here. I think I'll use the red pen. Okay, realize this is x squared minus 3x, right? Greater than a. We said x squared minus 3x is to fit over x squared minus 3x greater than a. We said x squared minus 3x greater than a. So I can take this to be my a because this is this, right? This is this. So I can take this pronouncer to be equal to a. So a is equal to this. So I have x squared. We have that x squared 3x is greater than b minus 3. So with b always greater than 3, remember, on choisit a égale à b moins 3. That is because to have this, you see I can take a to be equal to this because this and this, they are the same. So I can say a is equal to this. And then if we do that, what are we going to have next? I can say a is equal to b raised to the power of 2 minus 3b. Yes, exactly what you're thinking. This looks like quadratic. That's how we're going to resolve this question. So we're going to have b squared minus 3b minus a equal to 0. That's why I brought my a here and then became equal to 0. And you might be surprised that, wow, this is like a different thing from what we are used to. Like, how did this come in? But yes, when you try out more exercises, you probably might get used to it, which is what I am hoping for. And then I'll also be bringing in more questions so that we can all get to improve together. So what else? We've calculated delta. We know delta is what? B squared minus 4ac from quadratic. So what is b? B is negative 3. So if I have negative 3 au carré minus 4 times b is 1,